This videocast is aimed at Key Stage 3 and Year 10 in particular, and it teaches the properties of reflection of light. In this videocast we are going to learn how light is reflected in a plane mirror and then how to draw ray diagrams to illustrate that reflection property, and we're going to learn about the law of reflection. Initially then, what is reflection? Well, when we shine a beam of light at a mirror, it is reflected by that mirror and into our eye, reminding ourselves, of course, that how we see any object is by light entering our eye, either directly from the source or reflected off the object. So we know already that plane mirrors reflect light into our eyes, and this is how we see images reflected in the mirror. But we need to learn more scientific information about reflection. To do that, we can carry out an experiment using the ray box. And if we shine a ray from the ray box at an angle, and we shine that ray towards the plane mirror surface at an angle, we will see that it is reflected. To be able to do this experiment and to learn something from it, we initially start by setting the mirror on a plane page and we draw along the edge of the mirror. We then use our protractor to draw a normal line, and this normal is always at 90 degrees to the surface of the mirror. Then use the ray box to shine an incident ray at the mirror, reminding ourselves an incident ray is the incoming ray or initial ray from the ray box. We then find this is the incident ray, and the ray of light is reflected off the surface of the mirror, and we call this the reflected ray. When we're carrying out this experiment, what we're interested in is angle I and angle R. Angle I is angle of incidence, and angle R is the angle of reflection. Now we need to be very careful where we measure these angles, because the angle of incidence is the angle between the incident ray and the normal. That's very important that you get that right. And the reflected ray is the angle of reflection rather, is the angle between the reflected ray and the normal. So every time we measure an angle in reflection, it's always the angle between the ray we are considering and the normal. So the normal is a very important line in our diagrams. So what we do is we do this experiment, we measure the angles of incidence and reflection and record the results. Then we move the ray box round to alter the angle of incidence. You can either make it larger or smaller by making it wider, i.e. closer to the mirror, or further away from the mirror in an arc shape. So we repeat this for various angles of incidence and reflection. And what we find is that the angle of incidence is always equal to the angle of reflection. And this forms a basic rule of the properties of reflection. So no matter what angle of incidence we change this to, if the ray box is pointed at an angle to the mirror, the angle of reflection will always be the same. So as a result of this, we can draw a reflection ray diagram. And frequently in tests, this would be a standard question, would be to draw a ray diagram for reflection given the angle of incidence. And the first thing that we must do is lay our protractor on the surface, the line which is the surface of the mirror. So this is our mirror line. And we lay the protractor on and we find the 90 degrees. And we then take our ruler and draw on the normal, reminding ourselves that the normal is always at 90 degrees. Now, if we are asked to draw a reflection ray diagram for an incident ray of 30 degrees, we again set our protractor on, making sure that it lines up carefully with where the normal meets the mirror. And the angle of incidence we were asked was 30 degrees. Now, remembering our learning from the last slide, the angle of reflection then is also 30 degrees. And remember, the angle of incidence and reflection are always measured from the normal. So you can either set your protractor on and count round 30 degrees, or perhaps better practice would be to turn the protractor round so that the 0 line is on the normal, and then we come round to our 30 degrees. And this is then the angle of incidence. This is our incident ray, which we join up and this is the angle of incidence. Then we repeat this for the reflected ray. Now, having drawn the reflected ray and marked the angle of reflection, there are several points that you need to take note of when you're drawing ray diagrams. First of all, we always use a pencil in case we make a mistake. Secondly, you must use a ruler. Light travels in straight lines, and you must show that clearly. You must use a protractor to ensure that the angles of incidence and reflection are measured accurately and marked accurately and are equal. You must label each ray and angle, and you must put arrows on the rays to show the direction that the light is travelling. So the incident ray travels into the mirror and the reflected ray travels away from the mirror. Okay, another interesting point about reflection is the property of lateral inversion. A plane mirror reflects light regularly so that it produces a clear image which is the same size as the object. Think about whenever you look in the mirror. But what is different about the image? In this case, we can see the word physics reflected in the mirror, and we can see that it is now back to front. And this is the same whenever we're looking in a mirror. When we're perhaps brushing our hair with our right hand, it looks like we're using our left hand. So when something is reflected in a plane mirror, left becomes right and right becomes left. And this is called lateral inversion, which is a useful term for you to learn. So having learnt then about reflection, let's summarise our main learning points. Pale and shiny surfaces are good reflectors, if you think about a mirror surface. Dark and rough surfaces are not. The second point is what we've just learned, that the image in a plane mirror is laterally inverted. In other words, left becomes right and right becomes left. But note that it is still upright. The image is the same distance behind the mirror as the object is in front, and the image in a plane mirror is the same size as the object. Now, when we were creating the ray diagrams and doing the experiment of reflection in class, we learned that the angle of incidence is always equal to the angle of reflection. And this is true in every case. But you must learn this is called the law of reflection. Now, there was one exception to this law as such. If we shine a ray along the normal into the mirror surface, we will find that it is reflected back along the same path. Now, I said this was an exception. It's not really when you think about it, because when we shine a ray along the normal, the angle of incidence is 0. In other words, the angle between the ray and the normal is 0 degrees, and the angle of reflection is 0. So when we shine a ray along the normal,